M1 vectors, example 14. This is very similar to the previous example where we used R equals R0 plus VT, but there's an extra little twist which we'll come to here with the 15. So it says at time t equals 0, a particle has position vector 4i plus 7j. So that's this R0 here. So it's originally 4i plus 7j. It's moving with a speed of 15 in the direction 3 along, 4 down, 3i minus 4j. Now, if we just pause at that point and have a think about what's going on there, if we have a direction 3i minus 4j, then using Pythagoras theorem, the length of this vector here would be 5. 9 add 16 is 25, square root it, you get 5. So if we use this as our velocity vector, 3i minus 4j, that means it's going with a speed of 5. But the question says it's going with a speed of 15, so that can't be right. So it's going in the direction 3i minus 4j, but 3 times as much. In other words, what we do is we'll put a 3 in front of there. That will make this vector 3 times longer. In other words, it's 9i minus 12j. And if we just check that, 9i minus 12j, if we do a quick Pythagoras theorem on this, it's going to be 81 plus 144, 81, 144, and that gives you 225, and the square root of 225 is 15. So what we've done is we've actually made this 3i minus 4j 3 times bigger in order to ensure that its magnitude or its speed is correct. So, returning to our formula, position vector at any point is the starting vector plus, this is our velocity vector, 9i minus 12j multiplied by t. So just for the practice, I'm going to work out that general position vector that I mentioned earlier. So how many i's have we got? We've got 4 plus 9t I, and then we've got 7 minus 12t j. So that's the general position vector, and it now tells us that it's only going to be moving for 2 seconds. So we substitute 2 into here. 18 add 4 is 22. And then here we've got 7 take 24 is minus 17. So it's add minus 17j, which we can just write as minus 17j. Now, because this is r and it's a position vector and we were moving in meters per second, the units there will be meters.